What's up, guys? This is kind of a cool little setup, but we're doing some real world problems, so let's get started. Okay, we're going to do 4 problems, but we're only going to really set up and completely solve 2 of them. So let's get started. The first thing we always want to talk about is what's going on. We want to talk about the unknowns. Okay, so the unknowns are always our first priorities. So let's go ahead and read. So up here at the top, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen's ticket and the price of a child's ticket. So the 2 things I don't know is usually found in the very last part. So it's find the price of the senior citizen and child ticket. So my 2 unknowns are the senior citizen and the child ticket, and we're talking about the price. Okay, so we got to give it a variable, and the best thing would probably be S for senior citizen and C for child. Now we need to come up with 2 equations. So I'm going to write 1 right here to denote the first equation. So let's go ahead and we'll get started with that. The first thing is the first day. So we can make an equation out of the first day. They sold 3 senior citizen tickets. That's 3 times the amount of senior citizen tickets, plus they sold 1 child's ticket, and that equaled a total of $38. Next, it says the second day, so this would be our second equation. Now, it doesn't always work in this exact fashion, but in this case it does. And the second day, it said it sold 3 senior citizen tickets again, plus we get 2 child's tickets. And that was for the price of $52. Okay, so this one we're actually going to solve. So I told you we're going to solve 2, set up 2. So this one will actually solve. And when we're looking at this, we should think to ourselves, we should probably go ahead and do elimination. Everything's lined up for us, the S's and the C's. So let's go ahead and do elimination. And what I'm actually going to do here is I'm going to, instead of add, notice the 3 and the 3, they're the exact same. So instead of adding them, that would make 6S. I need to subtract them. So 3 minus 3, that goes to 0. There's my elimination. 1 minus 2 is a negative 1C. And 38 minus 52. Okay, so the difference between those is actually 14. And the 52 is bigger and it's negative, so it's a negative 14. Well, I have a negative and a negative, so actually we can divide the negative 1 out on both sides. And I get C equals 14. So the child's ticket's $14 essentially. Alright, now I need to plug that back into one of the original equations. I'm going to plug it in this top one. So 3 times the senior citizen plus 1 times the $14 child ticket equals $38. That gives me 3S plus 14 equals 38. Subtract the 14 from both sides, and we get 3S equals, this is going to become 24. Divide by 3, and that goes in 8 times, so the senior citizen ticket is $8. Okay, so again, setup, we start with our unknowns, we get our equation with variables, and then we try and set up 2 equations. In this case, we did elimination. Okay, so very nice job. Now I got to do a little bit of moving and grooving. So let's go ahead and go down here, and let's pick our next question. Okay, I want to make sure I get the good one that I wanted. Let's see. Here we go. Okay, we'll talk to Brenda. There we go. And we're going to go ahead and clear the page. We can start with a fresh page. Alright, cool. So let's get started. Brenda's school is selling tickets to a spring musical. On the first day, the sales listen sold 3 senior citizens, 9 child tickets for a total of 75. The school took in 67 on the second day. What is the price of a senior citizen child ticket? Now this is the exact same problem, just different numbers. So I want you to go ahead and set this one up on yourself. Go ahead and pause the video right now and set it up. Okay, hopefully you paused it, you set it up. Here's how we do it. Again, we want to start with our unknowns, what we don't know. And once we start with that, then we can go ahead and get the rest. It says, what is the price of a senior citizen ticket and a child's ticket? So we're going to start by saying, what's the senior citizen ticket price and what's the child's ticket price? Okay, and so we don't know either of those. Just like before, I'm going to give it an S and a C. Just like before, we have 2 days. The first day of school, they sold 3 senior citizens, so that's 3 times S, and they sold 9 child's ticket for a total of 75. Number 2, on day 2, they took in $67 and they sold 8 senior citizen tickets and only 5 child's tickets. Okay, so there goes. There's the setup. That was nice and easy. So I wanted just to do a setup one of that. Hopefully this is what you got, and then we could use elimination, but here we'd have to multiply. So let's go ahead and let's get another one in there. Okay. Whoops. Going too far down. Let's do this one right here. Clear the page. Alright, we gotta move this down just a tad. Alright, the State Fair is a popular field trip destination. This year, the senior class at High School A and senior class at High School B both planned trips here. Senior class A rented and filled 8 vans and 8 buses with 240 students. High School B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and in each bus. So what are my unknowns? Okay, my unknowns are the number of students in the buses and the vans. Ooh. So those are my 2 unknowns, number of students in the buses and the vans. So I'm going to give B for buses and V for vans. Okay? Alright, well we have 2 different high schools, so that's actually going to help me with my 2 equations. I'm going to do High School A as my first equation. High School A rented 8 vans, so that would be 8 times V. Plus, they also rented 8 buses, and they filled up 240 students. Versus High School B, they rented 4 vans, and they rented 1 bus, and they filled up 54 students. Okay, we're actually going to go ahead and solve this one. Again, this one's set up by using elimination. This time we don't have the same coefficient. Notice we have 8 and 4. That doesn't work, and 8 and 1. So we're going to have to multiply here in order to do this. Okay, well, we can do this. If I multiply this downstairs equation by 2, I would get this to be 8. But let's get it to be negative. So let's go ahead and do negative 2. This would give me negative 8v minus 2b equals 54 times negative 2 is going to give me negative 108. Alright, let's write the original equation on top, which is 8v plus 8b, that's this equation here, equals 240. Now we can go ahead and add these 2 equations. 8 minus 8 is going to go to 0. 8 minus 2 is going to be 6. And 108 minus 240 is going to be 132. That's a 6b, by the way. Divide by 6, and we get the amount of buses to be, amount of kids that fit on a bus. 6 into 132, I'm going to use a calculator off screen here real quick, and I'm going to get 22 students. Okay, let's go ahead and bring this up so we have some more space. So I have on bus B, on the bus, we can fit 22 students. So how many students can I fit in the vans? Well, I got to use one of the original equations. So I'm going to pick the bottom equation right here. 4v plus 1, instead of b, I can plug in 22 equals 54. This is going to be 4v plus 22 equals 54. Subtract 22, and I get 4v equals 32. Divide by 4, and I get v equals 8. So I can take 8 people in a van and 22 people in a bus. And that makes sense because buses are bigger than vans. Okay. Alright guys, so there it is, all set up. But let's do our last one, and the last one is just a setup question. Go ahead and clear all this. Alright. And this is the last one. We're going to set this one up here. Matt and Ming. Sound like good people, huh? Whoops. Past Matt and Ming. There they are. Okay. Matt and Ming. Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Matt sold 3 small boxes and 14 large boxes for a total of $203. Ming sold 11 small boxes and 11 large boxes for $220. Find the cost of the small and large box. Go ahead and pause the video, try and set this one up on yourself. By yourself. Alright, my unknowns. I have a small box and I have a large box. So we're going to call that S and L, small and large. Okay. We have 2 equations. We have the Matt equation, where Matt, he sold 3 small boxes plus 14 large boxes for a total of $203. And the Ming equation is 11 small boxes plus sold 11 large boxes for a total of $220. There you go, perfectly set up. That could be solved as well. Alright guys, thanks for the video. Ciao, ciao.